Hello everyone, my name is Gaurang Gupta and today we will be doing another machine learning project which is campus placement prediction for engineering colleges. In this we have the data in the CSV file placement_data.csv, and then we have to predict the placement status based on these parameters like number of internships done by a student, aptitude test score, soft skills rating, extracurricular activities, etc. So it is a problem of binary classification. In this we have two classes, placed or not placed, and then we have to classify the points or the data into these two classes. So let's move on to the code. So first we will import all the necessary libraries, which are import numpy as np, import pandas as pd, import os, import matplotlib.pyplot as plt from sklearn dot model selection, import train test split, not double s, test split, and grid search cv from sklearn dot preprocessing, import standard scaler and label encoder from sklearn dot svm, import svc from sklearn dot metrics, import accuracy score and confusion matrix from mlextend dot plotting, import plot confusion matrix, import cbond as sns, import matplotlib. We have already imported matplotlib, so from sklearn dot linear model, import logistic regression from sklearn dot ensemble, import random forest classifier, ada boost classifier and gradient boosting classifier from sklearn dot tree, import decision tree classifier from sklearn dot Gaussian process, import Gaussian process classifier from sklearn dot neighbors, import k neighbors classifier from sklearn dot Gaussian process dot kernels, import rbf, import xgboost as xgp. Now let's run it. So the code is executed correctly. Now we will import the data into our code. For importing data we will use for dir name comma underscore comma file names in os.walk, then /kaggle/input for file name in file names print os dot path dot join dir name and file name. Let's run it, and here you can see we have the path of the file. So let me show you this path. Here in the folder you can see we have this campus placement for campus placement data for engineering college, this folder name, and then the file present in it. So now let's make a data frame. It will be data equal to pd dot read csv, then the path which we will copy from here, control C, control V. Then we will print the list of columns, so data dot columns, and we will typecast it into list, and then data dot head. So let's run it. Here you can see we have now the list of all the parameters. Let me close it. All the columns, or you can say parameters, whatever you like, student id, cgpa, internship, and here we have the head of data, like the first 5 rows of the data. You can use any number of rows. It's just for getting the idea of data. You can use here 10, so it will print the 10 rows, first 10 rows. Now let's move on to data preprocessing. So for data preprocessing we will use a variable lb equal to label encoder, then data placement status will be equal to lb dot fit transform data placement status. Same we will do for placement training equal to lb dot fit transform data placement training, then data extracurricular activities will be equal to lp dot fit transform data extracurricular activities. So it will be here. Then data equal to data dot drop student id access will be 1, outputs equal to data placement status, and inputs will be data dot drop placement status, and access will be 1. Then std equal to standard scalar, and inputs will be std dot fit transform inputs. So now let's run it. Now our data is in mostly correct form. So now we will check whether the data has some nulls or not. So is na dot sum. Let's run it. So here you can see we have no null values, which is a good sign, because then we have to not worry about the nulls. So now let's move on to data visualization. So for data visualization we will first use data.describe. Now let's run it. So here you can see we have the description of every column, like how many entries are in it, what is the mean of every column, standard deviation, minimum, and all that data, so you can see it. So now we will we will plot some graphs to further visualize the data. So plt.figure, fixed size will be 15, 10. You can change the size accordingly as you like it. So sns.heatmap data.core line widths will be 3 and annotations will be true. Then plt.show. Let's run it. Here you can see we have the heat map which shows the correlation between different attributes or columns. So here you can see CGPA is directly proportional to placement status, or you can say placement status is directly proportional to CGPA. So here you can see we have different correlation values. So HSC marks has the most impact on placement. No, the aptitude score has the most impact because it has 0.52 value. So you can visualize that which parameters are more important than others, or which you want to drop depending on your requirement. Now let's see the effect of internships on the placement status. So for this we will define a variable internships effect will be equal to data.pivot table, which will be and it has an index of placement status, then values will be CGPA, then columns will be internships, and aggregation function will be count. Then let's see what the internship status pivot table is. Internships effect internships. Let's run it. So here you can see there are number of internships and then the placement status. So 0 internships, not the good chances of placement. If you have one internship, there are chances of placement, more chances than 0. And if you have 2 internships, most of the time you are getting placed. So let's visualize this data into a table, into a graphical format. So to draw a graph of this table, we will use x equal to internships effect dot columns, then x-axis will be np.arange len x, then plt.bar x-axis minus 0.2 internships effect dot ilog 0 colon 0 comma colon and 0.4, then label will be not placed. plt dot bar x-axis plus 0.2 internships effect dot ilog 1 comma colon 0.4, and then label will be placed. Then plt dot xtext x-axis x, plt dot xlabel number of internships plt dot ylabel number of placements, plt dot title internships effect, plt dot legend, not fig legend, and then plt dot show. Now let's run it. So here you can see we have effect of internships in the graphical format. This table is turned into this graph. Now let's visualize the effect of CGPA on the placement. So CGPA effect will be data.pivot table, index will be placement status, values will be CGPA and soft skills. We are also getting the effect of soft skills also. Soft skills rating, then CGPA effect. Now let's run it. So here you can see a higher CGPA and a higher soft skill score signifies that you have a higher chance of getting a placement, because for CGPA you can see 8.01 CGPA is the, you can say, average for the placed students, and for the unplaced students or not placed people it is 7.46. We can also make a pair plot, so let's do it. SNS dot pair plot, and we have to pass the data. So let's run it. So it generally takes some time, because again it depends on the number of attributes you have. The more number of attributes you have, the more the time it will take. So give it some time and you will see a pair plot. So you can ignore this warning. This warning is nothing. So here you can see we have the pair plot. What pair plot do is it takes pair, means two attributes, and plot a graph between them. So you can see we have all the graphs. You can look at any two attributes and you will have a graph. For example, placement and CGPA, placement and internship, placement and projects, HSC marks and projects, and so on. So now let's move on to the testing and training of some famous models and see how much accuracy we can get. So xtrain, xtest, ytrain, ytest will be equal to train test split inputs outputs. Test size will be 0.2, 0.2, and random state will be 0. Then we will define an array of models. So SVC support vector, then logistic regression, here the C will be 10, logistic regression, then random forest, wait a minute, random forest classifier, random forest. Let's define n estimators will be 20, n estimators will be 20. Then decision tree classifier, max depth will be 7, decision trees, then k neighbors classifier, n neighbors will be 7, and the name will be k neighbors classifier. Let me copy it. Then xgb dot xg boost, xg classifier, objective will be binary, colon logistic, then random state will be 42, and the name we will use xgboost, then ada boost classifier, n estimators will be 25, and ada boost, then gradient boosting classifier, n estimators will be 50, learning rate will be 0.1, max depth will be 10, random state will be 0. Wait a minute. And the name is gradient boosting. Now for I in models, name will be I1, model will be I0, then we will print the name. Now we will train the model.fit x train y train, then y pred pred will be model.predict x test, then print accuracy score y test y pred into 100, CNF will be confusion matrix y test comma y pred fig comma ax will be plot confusion matrix confmat equal to CNF, then plt dot show, and then for space print a new line character. So now let's run it. Now it will test every model and give us the accuracy of each model and also its confusion matrix. So it is running. So here you can see support vector is giving 79.95, logistic regression 80.05, random forest, decision tree, k nearest neighbor, xd boost, ada boost classifier, ada boost is giving 80.25, gradient boosting 78.5, and I think it is completely executed. Let me check it. Yes, it is executed. So we have seen that ada boost classifier is giving us the best performance. So let's move on to model optimization and optimize the ada boost classifier even further so it can give us the best accuracy we can achieve. So model will be ada boost classifier, then grid will be equal to an empty dictionary, grid n estimators will be 10, 50, 100 and 500, then grid learning rate will be 0.0001, 0.001, 0.01, 0.1, 1.0, then from SKLearn dot model selection selection, import repeated stratified k-fold, repeated stratified k-fold, then CV equal to repeated stratified k-fold, and splits will be 10, and repeats will be 3 repeats, and random state will be 1. Then grid search equal to grid search CV, estimators will be model, not estimators, it will be estimator. Then param grid will be grid, and jobs will be -1, scoring will be accuracy, and CV will be CV. Then grid result will be grid search dot fit xtrain ytrain print best %f using %f percentage grid result dot best score, comma grid result dot best params. So let's run it. So let's code the accuracy code, so where we will test the accuracy of this new model. So ypred equal to grid result dot predict x test, then print accuracy score y test ypred into 100. CNF will be confusion matrix y test ypred, then fig comma ax will be plot confusion matrix confmat equal to CNF, then plt dot show. So let's also run it. So now the code is executed, and here you can see we have achieved a maximum accuracy of 80.55%. It is not much of an improvement, but yes, it is surely an improvement. So you can further improve it, because I have used n estimators as 10, 50, 100, 500. You can use 10, 20, 30, 40, 50, and then if some more accuracy can be achieved, you can do that. So if you achieve more accuracy, do comment in the comment section. I would love to see how accurate the model can become. So for now, our project is complete. Thank you for watching the video. If you like it, please do like, share and subscribe to my channel. So thank you very much for watching the video. Thank you.